Okay, it's a quick overview of the reactions of the alkenes. This is in the C7 topic. So an alkene has a functional group with a carbon-carbon double bond. So that's what we're going to be looking for when we draw the displayed formula, which looks like this. So here's an example of the functional group. The carbon-carbon double bond can be anywhere on the molecule, so it doesn't always have to be between carbon 1 and carbon 2. All of the alkenes always match up with the general formula, so they all have twice as many hydrogens compared to the number of carbons, and there's a double bond that creates that. There's no methane, so you do need to learn the sequence of the first four. So we don't have methane, so the first one for the alkenes in this group is ethene, propene, butene and pentene, so they all end in ene for the alkenes. All right. You can test to see if something is an alkene by reacting it with something called bromine water. Bromine water will change from being an orange colour to colourless. So this is a liquid that you're going to add to your alkene. This might be in a test tube or a boiling tube, and you shake it up and you can watch the colour change. All right. Now you can react the alkenes with oxygen. So this is oxidation, burning we call this, and they produce a smoky flame. In complete combustion, if you've got plenty of oxygen around, then all of your alkene is going to react to produce carbon dioxide and water. However, if you've got a reduced amount of oxygen, so remember a balanced equation is just a ratio of all of our different atoms or molecules in a chemical reaction, I haven't got as much oxygen in the environment as I did before. So as a result, then I can't turn all of the alkene that we're reacting into carbon dioxide. Some of it turns into carbon monoxide. In the following lesson, we're going to be looking at some more of the reactions, and we're going to be looking at how we perform polymerization, specifically additional and condensation polymerization. But for now, we just need to be aware that the alkenes can react in a way where we break the double bonds. This has to be in the right conditions, so we can take lots of these together, break the double bonds, and you can link them all into a chain, and we can turn lots of individual monomers into a polymer. So if these were lots of ethenes, which they are, you can then connect them all together and you can make polythene. We can also do some other clever stuff with the alkenes as well. So we can do something called hydrogenation. So hydrogenation simply means adding hydrogen to our molecule. And what happens there? The carbon-carbon double bond breaks. The hydrogen molecule can then react. Again, this is in the right conditions. And you can see that the two hydrogen atoms as part of this molecule are now connected here to the carbon. So we've lost the double bond, which was here, and now we have a single bond. And we basically turn an alkene into an alkane. And the name just changes. So if this is ethene, then it becomes ethane, propene, propane, and so on. We can do a similar thing with the halogens, because the halogens are molecules of two atoms as well, F2, Cl2, Br2, and so on. We can react them in the same way. Again, in the right conditions, we can break the double bond. And in this case here, we've got the two bromine atoms of a bromine molecule, and they combine here to the two carbons via a single bond. And this is an example of what happens with the bromine water. So this would be orange bromine water, and then reacted with your alkene, and then it becomes colourless. We also need to be able to name this molecule. So there's three parts to naming it. We say di because there are two bromos for bromine, and then ethane because this is the structure now of the molecule. So it's very similar to an ethane molecule. If we were to use fluorine, it would be difluoroethane. And if it was chlorine, it would be dichloroethane. We could also use a different alkene, such as butene, and it would be something called dibromobutane. So there is different ways of naming these. So you need to be familiar with all the combinations there. We can do another reaction as well. In this case, we can use steam. So if we react our alkene with some steam, we can make an alcohol. All that happens again, we break the double bond, and our water molecule now combines to the gaps that are left over by our two carbons. One of the hydrogens reacts with one of the carbons, and that leaves the oxygen and the hydrogen as a pair to then join. Now, oxygen can form two covalent bonds, which is why it can pair up with a hydrogen and the carbon at the same time. And this OH is called the functional group of an alcohol. So all alcohols have this OH group in them. We also changed the name now, so it's not ethene anymore, it is now ethanol. So we keep the prefix at the beginning, but we change the ending to anol. So now you're going to go from butene to butanol, pentene to pentanol, and so on as well. Okay, so let's look a little bit more about the alcohols, because now we've touched upon that, there's a few extra details that we need to be aware of. So the alcohols can be produced via a more natural process called fermentation, which is where we take yeast and we put the yeast in with some sugar, for example, and put them in anaerobic conditions, which means we reduce the amount of oxygen they've got to respire. And as a result, then they will produce alcohol as a waste product. All of the alcohols end in anol, so we've got ethanol, propanol, butanol, pentanol. You need to be aware of those four and be able to recognize them in the displayed formula, but also written out as a chemical formula as well. Now, this displayed formula is written out like this. We can see we've got the 2 carbons, here they are, C2. I've got my 5 hydrogens. I've got one from the original water molecule, then 2, 3, 4, 5. So it's C2H5. And then the OH group we write as OH. And that just tells us a little bit more about the molecule, that it is an alcohol. You could write C2H6O. That's correct, because we've written all the atoms out. But this way it tells us a little bit more about its structure. The alcohols can be used for lots of different things. We can use them to make solvents, we can use them to make fuels, so we can burn them, so that's combustion again, and they can also be used to make alcoholic drinks. You can react alcohols with oxygen, so oxidizing them, and you can produce a carboxylic acid. So we're going to have a look at that in the next lesson. And then finally, these alcohols dissolve in water to form neutral solutions. So this is your overview then of the reactions of alkenes as part of the C7 topic.